Hello, and today's learning target is I can solve a system of equations through substitution. Today we are going to continue looking at solving equations. However, today both the equations that we see will be in standard form, but we still want to use substitution. So in this first example here, in order to use substitution, we are going to rewrite one of the equations into slope-intercept form. So let's rewrite the first equation into slope-intercept form. If I do that, I need to first rewrite the equation, add 5x to both sides, because again we want to isolate y for slope-intercept form. So y equals 5x minus 3. Now, I'm going to circle what y equals and substitute that in for the second equation where I see y. And I have 3x, and let's change this to a negative 8y. That was a typo there. It should be minus 8y. So 3x minus 8 times the quantity, again, because we're substituting in the expression. So 5x minus 3 equals 24. And distributing the 8 to both terms gives us 3x minus 40x plus 24 equals 24. I'll go ahead and combine some like terms. Get negative 37x plus 24 equals 24. Subtract 24 from both sides. Get negative 37x equals 0. Divide by negative 37. But 0 divided by any number gives us 0. So x equals 0, so now if I substitute that back in to one of the equations here, and I can substitute it back in to this equation right here that we rewrote to slope-intercept form, and get y equals 5 times 0 minus 3, and 5 times 0 is 0, so y equals negative 3. So my ordered pair here is 0, negative 3, and that's the solution to this system of equations. Okay, let's continue on to the next example. So I see two equations again that are written in standard form. So if we rewrite one of the equations into slope-intercept form, I'll go ahead and do that to rewrite the second equation because I see just a 1y, where up in the first equation I see a 3y. So it'd be much easier to rewrite the second equation into slope-intercept form. So I'll go ahead and I'll add 5x to both sides and get y equals 5x plus 13. Now I'll take the expression that y equals and I'll substitute it back in where I see y. And then I get negative 3x plus, to fix my stylus here, plus 3 times the quantity, 5x plus 13 equals 3. Distribute that 3 and get plus 15x plus 39 equals 3. And then negative 3x plus 15x is 12x plus 39 equals 3. And I'll subtract 39 and get 12x equals negative 36. Divide everything by 12 and get x equals negative 3. Now I'll take that answer and I'll substitute it back in for, let's use my slope-intercept form here and get and solve for y. So y equals 5 times negative 3 plus 13. So y equals negative 15 plus 13, and that would mean that y equals 2. So my final answer, written as an ordered pair, would be negative 3 comma 2 for this system of equations. So again, nothing too new that's added today, but added to today. A lot of twos to say, but we're starting with both equations written in standard form as opposed to already having one equation written in slope-intercept form. So just a little bit different there to begin our two equations. Okay, let's look at this next example here. X minus 2y equals 4, x minus 2y equals negative 2. So I see both of these equations with just a single x variable. And the y variable has like a negative 2 in front of it. So I am actually going to rewrite one of these equations in terms of the x variable. So I'm going to rewrite the first equation in terms of the x variable and get x equals an expression. Instead of y equals an expression, I'm going to look at x equals because that will be simpler for me to do in this particular example. So I'll rewrite x minus 2y equals 4, and I'll add 2y to the other side and get x equals 2y equals 4. So now I'm going to substitute this expression in where I see x in the second equation, and now I'm going to get 2y, and this should actually be a plus sign. I don't know why that's an equals. Whoops. And I should get 2y over here now again, plus 4 minus 2y equals negative 2. Again, we substituted that expression for x in for that second equation. I'll combine like terms. 2y minus 2y is 0y plus 4 equals negative 2. So 0y just goes away, so I get 4 equals negative 2, and that's not a true statement, right? Because 4 cannot equal negative 2, so that's false. That doesn't equal, they don't equal each other. So here there is actually no solution. So, and actually if you look back at the original two equations here, x, and then if we would actually rewrite this into slope-intercept form, since we have x minus 2y and x minus 2y, if we were to rewrite this into slope-intercept form, we would notice that the slopes are the same. And when you have the same slope, you have parallel lines, which means the two lines do not intersect, which means there is no solution. So we just found that as well mathematically. And again, that's just to talk about that parallel lines have the same slope. Okay. Let's look at the final example here. Okay, so I see the first equation says negative 3x plus 3y equals 9, and the second says negative x plus y equals 3. So I see a single variable y in the second equation, so I'm going to add x to both sides and rewrite this as x equals, or excuse me, as y equals an expression. That then I can take this expression and substitute it in the first equation in for y. So what I see is negative 3x plus 3 times the quantity, x plus 3 equals 9, where I'll go ahead and distribute that 3 and get negative 3x plus 3x plus 9 equals 9. Combine like terms, so 0x plus 9 equals 9, and when I have 0x, that just goes away. So 9 equals 9, which means 9 always equals 9, because that is a true statement, right? That is a very true statement. So here, these two lines are actually the same line. If we rewrote the first line into slope-intercept form, we would get the same line. So we have infinitely many solutions. And again, the last two examples here were the special cases for solving a system of equations. Thanks for listening. Have a great day. Bye-bye.